going to be looking at the logarithm time complexity, which is O log n, right? Now, in the previous lessons, we looked at the linear rhythmic time complexity, which is a combination of linear time complexity with logarithm time complexity, which is a big O n log n. So here we're going to be looking at logarithm time complexity, which is big O log n. Now, what is logarithm time complexity? Logarithm time complexity, which is denoted as a big O log n, describes an algorithm whose running time grows proportionally to the logarithm of the input size n. Now let's use a simple example of binary search of how the logarithm time complexity works, right? Now logarithm time complexity works with a solid array. So let's assume we have a solid array of n, which is a variable that holds a list of a solid array, which is 1, 2, 3, 4, 5, 6, 7, right? And we are told to find 7, right? So our target is 7. So how does this work, right? How does this work? Now, we'll use here to show our workings, right? So here in our working, so we have a target of this, right? So here we have a low. Our low will start from 0 and our high will start from the length of the length of n minus 1. So our length of n minus 1 is, you count the number of lengths here, number of items here, which is 1, 2, 3, 4, 5, 6, 7, right? 7 minus 1, which is 6, right? So this is 6. Now to get our middle, right? Now there are two ways to get the middle. You can say the high plus, you can say the high plus the low floor division 2. Now, this floor division is different from our normal division. Now, this floor division takes the odd number and exclude the numbers after the float, after the decimal point, right? But if you're using just the division operator like this, it takes both decimal points. So we want to exclude that. Now, using this floor division here, and our high here in this case is 6 plus 0, which is 6. 6 plus 0 is 6, right? Then floor division 2, which gives you what, 3. Now, now this in some programming language, this will lead to overflow, right? In some programming language, so just to play safe, right? So there's another pattern to use is low plus the high minus low, which will still give you the same thing. Now let's look at this. Now the low is 0 plus 6 minus 0, which is 6, right? Now 6 plus division 2 is 3, right? So 3 plus 0 is 3 plus 0, which is still 3. Now, in the case where the low is 4, now, in the case where the low is 4, if you're using that pattern, is the high is 6, right? 6 plus 4, which is 10 for division 2, is 5, right? Now, if you're using this pattern, let's say we have 4 here as a low, right? So it's now be 6 minus 4 is what? Is 2, right? 6 minus 4 is 2, right? Now 2 floor division 2 is 1, right? So 1 plus 4 is 5. So it's the same thing, right? So now this is the best pattern to use for to find a mid number, right? To find a mid number. Okay. Now we need to write a while loop. So while the low, right? So while the low is less than or equal to the high. So in this case, our low is 0 and our high is 6. So this stands, right? So this stands. So while the low is less than or equal to high. So what happens is, now, if we need to get the mid now, which the mid is equal to the low plus our high minus our low floor division 2, right? So to get the mid, right? So in this case, when we have the n equal to 1, 2, 3, 4, 5, 6, 7, right? And our target is 7. So in this case here, our in this first instance here within this while loop, our mid is what? Our mid is 3, which is 6 minus 0 plus division 2 is 3 plus 0, which is 3. So our mid is 3, which means that now if n want to get the the value in the mid, which if n is equal to our target, right? If it's equal to our target, then return the mid. Now, the first instance here, it's 3, right? So we need to get the value located in n3, n mid, which is 3. So which is 0, 1, 2, 3, which is 4, right? So our mid in this instance is what? Is 4, right? Is 4, right? Then our target is 7. So is 4 equal to 7? So this is actually false. Now this is false. So nothing happens within this rule here. So nothing happens. So now if the n mid, right, is less than our target. If it's less than our target, so what happens? We mean to have the low is equal to the mid plus one. Now search through the right hand side. Search right, that means the number we're trying to find is located on the right hand side. Else, the number we're trying to find, else the number we're trying to find is located in our left hand side, which is mid minus one. So now let's do this working here. Now, mid is equal to the first two, 4 equal to 7 is false. Now we have 4, then we have 4 here. We have 4. Is 4 less than, in this row, is 4 less than 7? Now 4 is less than 7. That means this row stands. This one stands. So if 4 is less than 7, our low becomes what? Our low becomes what? Our low becomes 3. Remember our mid was 3, right? Our mid was 3. So our low becomes what? 3 plus 1, which should give us 4. 4, right? Becomes 3 plus 1 will give us 4, right? So it comes again within this while loop now. Remember our low is now 4. It comes again within this while loop now, and then find a new mid. Remember, and find a new mid. So our new middle becomes what? 4. Remember the low is now 4. 4 plus our high is 6, right? 6 minus 4, 4 division 2. We give it what? 6 minus 4 gives you 2. Now 2 floor division 2 will give you 1. Then 1 plus 4 will give you what? 5. That is our new mid. So our new mid is 5, right? Our new mid is 5. Then if n of 5, which means that the 5 here is 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So the 5 is 6, right? So our new mid becomes what? Our mid now is this n mid now becomes 6. So if 6 is less than, if 6 is equal to our target, which is 7, so this is still false. This is still false. So this rule will not stand. So now it goes to the next one here, right? It goes to the next one here, which means that is 6 less than 7, right? Actually, 6 is less than 7. So it performs this one. So our low now becomes what, right? Our low now becomes what? Remember, our mid is now 5, right? Our mid is now 5. So our low becomes what? 5 plus 1, which will give us what? 6, right? Our low becomes 6. Now it comes again, it performs this while loop again. Our loop becomes 6. Is 6 less than equal to 6? Remember the I is 6. Is 6 less than equal to 6, right? The operation stands, right? The operation stands and it comes down here, right? And it comes down here. Now we look for our new mid. So our new mid now becomes what? Our new mid becomes what? 6, right? Remember the low is now 6. So 6 plus 6 minus 6, right? Then floor division 2, which will give you what? 6 minus 6 is what? Is 0, right? Now this floor division, this is what? Now 0 floor division 2 is 0, right? So 6 plus 0 is actually 6, right? So the answer, the mid is 6 now, right? So the mid is 6. Then it comes into this place here. Now it comes to this rule now. So n of 6 is, let's count it, 0, 1, 2, 3, 4, 5, 6. It means n of 6 is 7 now, which means is 7 equal to 7. Now if 7 is equal to 7, now this stands, so it will now return, so this is actually true, so it will return the number is found in index what? In index what? 0, 1, 2, 3, 4, 5, 6. In index what? In index 6. That is mid is equal to 6. So number is found in index 6. So that is what it will return. So it will return 6, right? So this will return 6. And we have actually found our number using the binary search, and the loop will then stop. It will not continue any further because we have found our answer. So that is how it works, right? So this is how it works. This is how the binary search works. You can see for every of the search, it makes a division, right? It makes a divide. So that is why it works on purely on big O log n, right? So this is how it works. I hope you understand that. If you have any question, please feel free to ask me, right? Feel free to ask me. If you are confused, feel free to ask me. I'm always here to answer you and then explain it better to you. Thank you and God bless you. So I'm going to make this function well. So within this while loop here, we have this, right? So within this if statement here, we have this. So within this one here, this if here, we have this. So within this, we have this, right? We have this. So this is just an algorithm to perform the binary search, right? So, but if the number is not found, right? If the number we're trying to look for is not found, it should just output not found, right? Outside this while loop, right? If the number is not found, it outputs not found. But geez, it's just this is an algorithm to show that the number. This is an algorithm to show that the number is within this list. But if the number is not found, all we just need to do is to put Let me just go back here. So I will do the algorithm very well. So if the number is not found, it should just output. Yes, it will output -1. Output -1. Not found. So within this while loop here, of this, so if number is not found, I put -1. Right? So this, we put this within this. So if this is this, return this within this loop here and this. So this is the algorithm for the binary search. I'll make this bigger. Okay, it's 24, so let me make it 20. Okay. Now, these are going from the binary search, and I've explained how the binary search work. So, if you have any question, feel free to ask me. I'm always here to assist you. I'm your instructor for any course you're trying to look for in computing. I'm always here to assist you, right? So, computing is very, very, very simple. Very simple. Right? Once you understand algorithm, you can write anything. Thank you, and God bless you.